Welcome to Personal Web Tutor. We've got a physics problem here on our hands, and the question is, a plane lands on the runway at a speed of 120 meters per second. The maximum acceleration that the body of the plane can handle is 7 meters per second squared. So the first question is, what is the minimum time for the plane to come to rest? And the second question is, what is the minimum runway length required? So the first thing we want to look at is, what are the givens? We have the initial velocity. V initial is equal to 120 meters per second. We want the final velocity to be equal to 0 because we want the plane to stop. And we have this acceleration max. In this case, it is minus 7 meters per second squared because the plane is stopping. So the formula that we know of is V final is equal to V initial plus acceleration times time. So now what I'm going to do is I'm going to substitute in our values. We got the final velocity we want to be 0, 120 meters per second, plus, but in this case it's going to be minus 7 meters per second squared times time. Now I'm going to subtract 120 from both sides, 120 meters per second. So I'm left with minus 120 meters per second is equal to minus 7 meters per second squared times the time. As you can see, we can add these plus signs here, cancel out the negative. And next we're going to divide by 7 meters per second squared, both sides. So I'm left with 120 meters per second. And when you divide, you can also multiply by the reciprocal, which is 7 in the denominator, 7 meters, and the second squared goes into the numerator, and that's equal to the time. Now, we got the meters cancel, the seconds, one of them up there cancels, and we are left with 120 divided by 7 seconds is equal to the time. That means that the plane is going to land, and it's going to take 17.14 seconds. And there we go. That is the answer. Next thing we're going to do is we are going to solve the second part of the problem. Now the second part of the problem was asking for the length of the runway. So the formula we're going to use here is going to be V final squared is equal to V initial squared plus 2 acceleration times displacement. So here we go. We're going to substitute in our values. The final velocity we want is 0. The initial was 120 meters per second. And we're going to square this whole thing. Plus 2, that acceleration was minus 7 meters per second squared. And then we have x. So I'm going to work this out. I'm going to square this. And I'm going to do minus 7 times 2. So I got 0 equal to 14,400 meters squared over seconds squared minus 14 meters per second squared times x. Now what I'm going to do is I'm going to subtract 14,400 meters squared over seconds squared from both sides. So minus 14,400 meters squared over seconds squared is equal to minus 14 meters per second squared times x. Now I'm going to divide by a negative 14 meters per second squared both sides. So I'm going to end up with minus 14,400 meters squared over seconds squared. And remember the reciprocal. And that's equal to x. And I got these seconds canceling out. Again, I got one of those meters canceling out there. So what am I left with? I am left with actually I forgot to do these plus signs here. I'm left with 14,400 divided by 14, and that's meters, and that's equal to x. And that gives us 1,028.57 meters. There we go. And there we have it. That is the length, and right up there, 17.14 seconds is the time. So, if you got any questions, please feel free to visit personalwebtutor.com. Go ahead and you can go to our main website here. And in the website, you have this little link here. It says Ask a Question. And when you click on that, you'll see that it brings you to a form. Go ahead and fill out, give us your message, give us your question, and you never know. Maybe your question will be my next video. Thank you.